Chatterley's principle. Discuss the effect of pressure, concentration, and temperature on the following reaction. N2 plus O2 gives 2NO. Le Chatterley's principle. According to this principle, if a system at equilibrium is subjected to a disturbance or stress, then the equilibrium shifts in the direction that tends to nullify the effect of the disturbance or stress. Consider the following equilibrium reaction. N2 plus O2 gives 2NO. Effect of change of concentration. At the equilibrium conditions, the reaction mixture contains both the reactant and product molecules, that is N2, O2 and NO molecules. The concentration of reactant and product molecules are constant and remain the same as long as the equilibrium conditions are maintained the same. If a change is imposed on the system by purposely adding NO into the reaction mixture, then the product concentration is raised. Since the system possesses equilibrium concentration of reactants and products, the excess amount of NO reacts in the reverse direction to produce back the reactants, and this results in the increase in concentration of N2 and O2. Similarly, if the concentration of reactants such as N2 and O2 are purposely raised when the system is already in the state of equilibrium, the excess concentration of N2 and O2 favor forward reaction. Concentration of NO is raised in the reaction mixture. In general, in a chemical equilibrium, increasing the concentration of the reactants result in shifting the equilibrium in favor of the products, while increasing the concentration of the products results in shifting the equilibrium in favor of the reactants. Effect of change of temperature. A chemical equilibrium actually involves two opposing reactions, one favoring the formation of products and the other favoring the formation of reactants. If the forward reaction in a chemical equilibrium is endothermic, that is accompanied by absorption of heat, then the reverse reaction is exothermic, accompanied by evolution of heat. Let us consider the example N2O4 gives 2NO2. DH is equal to 59.0 Kelvin joules per mole. In this equilibrium, the reaction of the product formation NO2 is endothermic in nature, and therefore the reverse reaction of reactant formation N2O4 should be exothermic. If the above equilibrium reaction mixture is heated, then this temperature will be raised. According to Le Chatterley's principle, the equilibrium will shift in the direction which tends to undo the effect of heat. Therefore, the equilibrium will shift towards the formation of NO2, and subsequently dissociation of N2O4 increases. Therefore, generally when the temperature is raised in a chemical equilibrium among the forward and reverse reactions, the more endothermic reaction will be favored. Effect of change of pressure. If a system in equilibrium consists of reactants and products in gaseous state, then the concentration of all components can be altered by changing the total pressure of the system. Consider the equilibrium in the gaseous state, such as N2O4 gives 2NO2. Increase in total pressure of the system in equilibrium will decrease the volume proportionately. According to Le Chatterley's principle, the change can be counteracted by shifting the equilibrium towards decreasing the moles of products. Hence, the reaction can be combination of NO2 molecules to N2O4 formation will be favored. In case of a gas-phase equilibrium, which is accompanied by decrease in number of moles of products formed, the effects of pressure can be considered as follows. N2 plus 3H2 gives 2NH3.
Please subscribe our channel for more videos and educational contents.